Bismillahirrahmanirrahim. My name is Nur Fazila binti Masdar, and in this video, my group will be presenting our review on ubiquitous computing in education domain. Now, let's get to know our main character first. What does it mean with ubiquitous computing? Ubiquitous computing as the interaction paradigm was first introduced by Mark Wizers in Xerox laboratories in Palo Alto in 1991. And according to Weiser visions, ubiquitous computing terms referred as a world where invisible computers would support people in everyday activities, offering boundless access to information resources anytime and anywhere. Ubiquitous computing, also known as pervasive computing, where it is environmentally embedded devices that enable constant, unobtrusive, and dependable communication and processing while performing value-added services, resulting in ambient intelligence. The spark of ubiquitous and social computing being implemented started because of the worldwide use of computer in all fields of human activities, together with the decrease of their price and the increase of their power and versatility have made them grow to tremendous popularity over the several last years. Moreover, technological advancements have paved the way for modern technology that work multifunctionally, like smartwatches and smartphones are unknowingly embedded into our daily life, making all the information and resources can be accessed anytime and anywhere, which is the key point of the ubiquitous and social computing concept.
Okay, now I will explain about application ubiquitous computing in education domain. Okay, ubiquitous computing is widely being used in the education domain, such as e-learning, which is ubiquitous learning. Okay, ubiquitous computing can be considered as the new height in the information and communication world. Okay, learning style has been progressed from this to this, which is from electronic learning, which is e-learning, to the mobile learning, m-learning, and then lastly to the ubiquitous learning, which is u-learning. Okay, because of the fast change in the learning environment, there is no specific definition in defining the u-learning because there were many different views from the researcher. Despite that, the term anywhere and anytime learning is being used to refer to the any environment that allows any mobile learning device to access learning and teaching content over wireless network in any location and at any time. Okay, one of the example of use of the u-learning is student learn automatically within the U-space or ubiquitous learning environment, ULE. Okay, each student have a wireless and mobile device, which is personal digital assistant PDA or mobile phone with headphone. Sensor will assist the ULE server module in tracking and locating each student within the U-space. Okay, the data from the object is transmitted to the student handheld device when the student approach the object. Okay, for the second one is a computer-supported ubiquitous learning environment for vocabulary learning using RFID text by Hiroaki Ogata, Ryo Akamatsu, and Yonio Yano. Okay, it is provide computer-assisted language learning, which is called in ULE. The technology is called Tango Tech-Aided Learning Object. Okay, the system use RFID, radio frequency identification text to identify item surrounding the learner and present the learner with the relevant language learning information.
Advantages of ubiquitous computing in education. Ubiquitous computing in education is a way of learning at your own pace and a more productive way where it is provided by ICT, information and communication technologies, and portable devices. It does not have any restriction that allow us to learn at any time and anywhere we want. The type of education that is accessible to everybody and allows them to learn in various circumstances. These technological advancements have enabled anyone to continue learning without using books or needing to go to a library. It can also facilitate teacher-guided and self-taught learning because numerous educational applications will enable us to learn alone and with others. For the first point is the learning efficiency. Ubiquitous computing offers an environment where students use their devices with which they can access a class from everywhere. It can also help them learn to collaborate with other students, experiment with appropriate software, and pose questions to their classmates or teachers. This method is more beneficial because the knowledge is built upon the student's experience by learning their own style. In the conventional technique that we have always used before, the teacher-centered class does not provide a chance for students to learn how they can build their knowledge through collaboration or experiment. So, there have been significant efforts that lead us in the direction of the ubiquitous computing revolution. For the second point is the productivity. Students can increase their productivity by using the newly developed technology. It helps students build their knowledge based on techniques that are proven by research that produces better outcomes. It also assists in increasing students' engagement with their lesson with pervasive courses in education. Students become more active, taking charge of their learning and working at their own pace. Furthermore, in the learning process, engagement with students with whom they share a common interest is crucial to attracting their interest in learning. And the last point is the access to technology. Every educational place has a computer lab. It has many computers in the lab for students to use, but students do not have limitless and timeless access to them. Nowadays, most students have their own devices to access lesson resources, either from their class or their home, because of online learning due to COVID-19. The usage of technology is second nature to all of the students to become a class of technologically equal students in the use of technology. Over the past few years, there has been a digital divide where there is a gap in technology access and inequalities in different fields. Nevertheless, when the student has a device such as smartphone, it gives an excellent opportunity to them limitless access to digital information, augmenting their productivity. These advantages of ubiquitous computing in education. Even though there are many benefits and the possibility of limitations, a few things need to be considered. Like all the other areas of technology, ubiquitous computing has some disadvantages. First point is the cost. Each student will have their own device to accomplish activities, will incur a cost at 2 points. The first point is the financial cost, with which the cost of providing a large number of devices is prohibitive. The second point is a cost in transforming the traditional system into the new one. However, many things must change due to the use of new technology, such as the lesson plan, the teaching style, and the assessment model, that will necessitate significant effort on the part of both teachers and policymakers. And the second point is the teacher expertise. This type of program necessitates the skill of teachers in terms of technology and the design of innovative course formats. Since teaching and learning make all students and teachers use electronic documents, the internet, access to a wide range of software and other digital resources. Teachers must be well versed in this educational environment because this ubiquitous computing in education will make learning more advanced. It will be a burden for teachers who are not competent with technology to explore the learning style. Additionally, there is a potential that they will not acceptably utilize technology in their teaching style. A solution to this issue is teachers' continue education to prepare them to deal within the new circumstances. So, it will feel better for a teacher before they apply ubiquitous computing in their learning and teaching.
Human-computer interaction HCI is likely to be seen rapidly changing from time to time and could have affected the nature of future computing. But what actually human-computer interaction HCI is? In brief, human-computer interaction HCI is a discipline concerned with the design, evaluation and implementation for interactive computing systems for human use with the study major phenomena surrounding them. In fact, HCI has gained a new dimension, particularly in the area of ubiquitous computing, because it implies scenario adaptation and support for multimodal user interaction and also involves the integration of intelligence work with the interaction paradigm. Why ubiquitous computing can be related to the future HCI? This is all because technology becomes more advanced every day. Ubiquitous computing integrates computers into human living spaces or equipment so that they are hidden from view and the user may concentrate on their task rather than the computer. It makes computing and technology more user-friendly, accessible to individuals with little technical knowledge, reliable and intuitive. The speed of the conventional method of HCI is still in use. There are some examples of future HCI that actually already exist nowadays in human daily life. Firstly, wearable devices which are microprocessor-based hands-free devices with the capacity to send and receive data through Bluetooth, Wi-Fi or cellular networks. Wearables have their challenges, such as GPS does not work and is even questionable in indoors and some urban areas, causing positioning to be important to detect the user location. In education, these devices increase student engagement as they allow students to be aware of the deadline for assignment submission and exam dates and reducing the likelihood of misunderstanding. Teachers also can create and share teaching schedule with students and teaching staff using these devices. Next, speech recognition or speech-to-text is a feature that allows a computer program to convert human voice into text. Speech recognition is concerned with converting speech from a verbal to a text format, whereas voice recognition is just concerned with identifying a specific user's voice, making people confused sometimes about these two. Because of many applications using speech recognition being developed every day, UI designers especially must always pay attention and stay up to date with all the technologies related to speech guided when developing the interface of the future system before entering market. Lastly are the virtual reality VR and augmented reality AR. Both of these offer more natural and efficient ways for a user to interact with a real or virtual environment. Virtual reality VR is the process of giving a person sensory input that simulates being present in a real or imagined world, and sensory input is most usually limited to sight and hearing, although it can also include other senses including touch. Augmented reality AR is a live direct or indirect experience of an area is layered with computer-generated sensory input in the form of images, video, and or sound. All devices contribute their various input and output capabilities to the common objective of providing consumers with a consistent, usable, and accessible user interface. Users should see this community of collaborating devices as a cohesive UI that always makes the most of the environment's present interaction resources. For instance, self-organization user interface. It can be defined as a process in which patterns at the global level of a system emerge solely from numerous interactions among the lower-level components of the system, where the pattern is an emergent property of the system rather than a property imposed on the system by an external or ordering influence. The interactions among the system components are executed using only local information without reference to the global pattern. Self-organization is used to connect a group of co-located interactive devices into an ad hoc community of devices that serve users as a single, seamless user interface, and often led to result in an almost miraculous and virtually optimal use of resources that is not the consequence of an external ordering effect or a top-down design. Natural interfaces introduce a new set of issues such as the ability to make new and different types of errors when utilized for recognition-based tasks. That is why system designers aim to eradicate them as soon as possible by enhancing recognition accuracy, and to make it worse, it is possible that eradicating errors will be impossible. But somehow, when it comes to the various types of communication, even people can make blunders. Besides, user happiness is not solely determined by recognition accuracy. Error handling is not a fresh issue because it is endemic to the design of computer systems that try to imitate human abilities. However, there are some effective methods that can be used for detection and correction of errors in recognition-based interfaces, like error reduction, which includes investigation into ways to improve recognition technology in order to eliminate and reduce errors, and also error discovery, that before either the system or the users may take any action in response to any error, one of them must be aware of the error and through effective output of questionable interpretation of recognized input, the system can be informed of an error and can assist the user in locating fault.
To sum up, it has clarified that whether relatively straightforward factors into two dimensions, which are user mobility and interaction transparency, that will serve as a clear border for ubiquitous computing, and explain the relationship between ubiquitous computing and future human-computer interaction (HCI). Okay, firstly, the user mobility that lets the user of a system engage with it in a limited number of areas. Each dimension of the ubiquitous computing framework is defined as the user's ability to move about freely while interacting with the system. Unlike desktop computing that needs user to sit and stay in front of the fixed computer to complete the task. Okay, next, the interaction transparency that refer to the system user interface and represent the user's conscious effort and attention required to operate or perceive the system output. To this interface, lack interaction transparency, causing the user to consciously observe, understand, and manipulate an interface that is conceptually separate from the task being performed in order to complete a task with the system. Okay, it also fades from the user's focus, allowing her to focus on the work at hand, such as button appearing on the interface. Greater directness can be found in all ubiquitous computing systems as a technique to reach some amount of transparency.
In conclusion, technological shifts have brought enormous impact to the education system, leading to the implementation of ubiquitous social computing that changed the pattern of educational itself. It is appeared to be the future of educational technology, forcing itself into school and education institutions soon, creating a pervasive learning environment that utilizes invisible computers such as wearable computers or sensor and computer-embedded objects. Therefore, it is crucial to study how well humans will interact and adapt to this technology.